capstone project for this course, and this is to model a combined cycle power plant. So I've downloaded the data set, it's in my downloads folder. So I'm just out of the three uh, methods to do this, like an Excel or Python or the Google Cloud ML. I'm choosing to do with the uh, Python as I have some programming knowledge in Python. So let me get straight to a Python notebook and let me get started. So here's the Python notebook and I'm gonna go over what I've done. So I've imported the pandas and numpy. I don't think I used numpy, but I just did it. So I use the pandas read CSV to get into a data frame, the data, and I'm trying to see the data that we have here. So we have this temperature, atmospheric pressure, the V value, and the RH, and then the final. This is our dependent variable, and these are our independent variables, which we may choose it as features. So in order to achieve this, I'm trying to use the linear regression, going with the multiple features for the linear regression model. So I'm going to select first all of them to see whether we can correctly predict the output correctly. So in order to select the data sets and features, I'm using the X variable and I'm dropping the column PE, which is obviously our target. I'm dropping it, and then so let me redo this. Okay, let me redo this thing. So I've loaded the data frame and I'm dropping the P. So let's just display the X. So I have for these four features. Then the Y I'm choosing as the target, just displaying the Y here. And now just looking at the data analysis just to see if there is a null value. Do we need to fill those up or something? So there's no null values. So I'm using the module from the sklearn for the train and split. So I'm creating my xtrain, xtest, and ytrain and ytest. These are going to be our features and these are going to be our output. So we have separate training and separate um, training set and separate test set, and I'm giving 30-70 ratios here. So like I said, I'll be using linear regression. So I'm using linear regression and trying to fit instantiated the linear regression object and try to fit the x train and y train. So let me run all these things now, like here, null, training set, and then this should kickstart our learning process here. I can check up the intercept parameters here, and which is coming to around 448, and I can also look at the coefficients. So I should see a four coefficients corresponding to the four features. There's a negative correlation I can see here, and then there are these two numbers, and the correlation is more higher for the temperature, I think. So now let's use the training to predict it. Uh, so now we have predicted and then we got an array of predictions. So now let's check whether the prediction matches with actual and whether we are able to correctly predict. So for that I'm just trying to use a scatter plot on the actual versus predicted, and I'm just trying to run it. So as we see, our we are able to predict almost with a very good accuracy. You know there are some things that we cannot predict, but we have done it. So now we can check how much is the variance by looking at the R score. So we are importing the R score and trying to. So the R score is 92, which is pretty good. 0.92. 1 is a perfect, but so we are able to almost accurately predict. That's good. Let's run this on the test value and see how we are able to test the predict, because we have never ran through the test values. Yeah, as you see, we can predict. Our prediction is looking great on the test value also. Let's do an R score on the test, and that's 93. So that's better. So on the test, we on a smaller set of data, we are able to predict much more better. So now, just to do a sample analysis to just drop a few fields and see how we can predict better. I'm just trying to drop a few features to see how it is. So yeah, target. So I'm trying to first identify, is there any uh, linear pattern that I can establish between those variables. So I do this. I'm trying first on the 80. 80 I get a negative. This is pretty good correlation. So I think I can use this as a feature. And let me also try with AP. This is not really something that it's not. I don't. I mean, in some way it is, but I can see the depth is so much, the width is so much, and I may not consider using AP. But RH, yes, RH also, it's not that correctly linear as what we get for the AT, and for the V, yeah, it looks in good. So based on these results, let me drop this uh, these two, which and try to create another training and see what's the result. So I created a new X based on just these two, which I think is maximum correlation. Our previous R score was like on training was 93. Let's see if we can get better. So I'm gonna rerun these things here, which is now we have new X. So let's, yeah, retraining it, and let's see the intercept calculated, coefficient calculated. Now we have two coefficient. Now let's train this now. We got the training, and let's plot it. Yeah, it's not bad. I mean, with just two features, we are able to like almost get a linear line there. So I can try to uh, get the R score here. Oh, R score is slightly lesser than the previous one when use four of these. Let me do it on the test and then calculate the R score. 91. So I think when we use the combine all those four features, that's when we get 93. That's when we get the best trained model. Yeah, I think that's all I want to cover from this project. Thank you.